Lightning talk today. And the idea of lightning talks, again, I'll just remind you, sometimes I think people forget, everybody can present a lightning talk. Anybody can. It could be a work in progress, anything that you just want to share. Please get in touch. It's very, the bar is very low, as you'll see. All right. Now that I've got your expectations set, let's get started. What is BLAS? Does anybody know or want to share? Go ahead.
Yes, the acronym stands for Basic Linear Algebra Subprograms. It's just a way to do the vector matrix, matrix multiplication.
Yeah.
Vector matrix multiplication, those type of things.
Yeah.
Original written in Fortran should be tuned to your machine.
Yes, that's a great description, actually. You should be giving this talk. So I'll just repeat what he said for those of you who couldn't hear. He said that it stands for Basic Linear Algebra Subroutines, and it is a collection of programs for doing vector and matrix math, right? So vector, 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 matrix, and matrix, matrix. And why the heck would we care about doing that? Yes, everything, almost. There's a caveat. At the end of the talk, I'll tell you the caveat. But yes, almost everything that we do in statistics involves those types of operations, okay? And with large pieces of data, those operations can be very costly. And so another thing Melvin said was that you would like to have these routines optimized for your machine, tuned to your machine. So that's kind of actually what we're going to talk about right now. What does that mean? Normally, when you guys download R, you come to this top part here. That's where they recommend you to go. Grab R's binary package and just install it from there. How many of you guys installed it this way? I think most of you. Okay. How many of you guys have not installed R? Okay. Good. Okay. So what I'm going to talk about, and this is actually, that's actually for what it's worth, that's where they recommend you to start. It actually says that there. Windows and Mac users most likely want to use one of these versions of R. I'm going to talk today a little bit about what happens when you go this route and why. And it's all about what Melvin said about tuning those particular routines to your machine. There are other reasons why you might do it, but this is the one that I think is a compelling reason. Here's some references. They'll be in the slides. Some stuff that I used when I was working on this. There's some benchmarks that'll let you test your machine and your configuration and how fast it can perform some of these routines. So I'm just going to actually open this one really quick. And you can see there's just a bunch of tests. And they're wrapped with timers. So it'll just time how long it takes to do X number of these, X number of these, and X number of these operations. And they're grouped into different categories of operations. And I want to draw your attention to the types of operations that are here. Let's see. So determinant of a 2500 by 2500 random matrix, decomposition of a matrix, inverse of a matrix, Fibonacci numbers, not sure how practical that one is, the Hilbert matrix, common divisors, just kind of scrolling through here. There are actually some at the top that I think would be interesting. Fast Fourier transform, linear regression on a 3000 by 3000, right? We use linear regression often. Like, I think that's something that's pretty universal. And so these things are all being timed. And what they do in this is they kind of do a trimmed mean, and then they report that. I wanted to grab all the numbers, so I slightly modified the script. But that's the set of benchmarks, and it's a very commonly accepted benchmark in R. Like, you'll see it referenced a lot when you talk about performance in R. I didn't use that other one. It was stupid. Sorry, it wasn't stupid. It was just, I didn't have time. So these are the libraries that I tested. Now, we talked about BLAS, and there are different flavors of BLAS. There are different ways to get it on your system. The easiest way, and the way that you get it when you go to that top section on the downloads page, is the reference BLAS. This is the BLAS that comes with R. It comes prepackaged. It needs all of those routines, and so it comes with its own. So if you've installed R and you didn't compile from source, that's the version you have. So that's one of the libraries we test with the benchmark. I actually am not including the outputs from Atlas because that is super specific to different parameters that you may choose. We're not going to test that one, but that one is an interesting one. MKL, which is Intel's math kernel library. This one's one that Intel built with their own knowledge of how their processors work, and they optimized it to take the best advantage of their hardware. And then Apple actually has a built-in library for BLAS, which is called Accelerate, and this one's comes with all your Macs. You all have it. If you have a Mac, you have this one. But it doesn't automatically compile with that when you install R on that system. So that's another one we test. There are some other ones that are interesting. There are a bunch of them out there, but these are some other ones that I wanted to draw your attention to. There's a BLAS, and this is for the NVIDIA GPU cards. GPU computing is something that's really interesting to me, and I hope somebody will come talk about it soon. Yeah. CUDA. You'll need the CUDA library on your system to compile this. Armadillo. This one's also interesting. This is kind of like a cousin of BLAS. It's not actually BLAS compatible in the sense that you will still need BLAS on your system. But Armadillo does get used in an R library that's pretty popular. And then ACML is kind of like the sibling of Intel MKL for AMD systems. All of them except the Apple one are.
All of them except the Apple?
Actually, yeah. So these are the computers that I use. So there was a Mac and there was a Linux system that was used here. And the Apple one isn't available for obvious reasons, but all the other ones are. Yeah. And Amanda was very generous and spent some time running my script on her MacBook Air. And then another system I used was my workstation I just built at home that I was really excited to test out, and that's kind of how I got started on this road. Imagine just like a bunch of wires and like, tubes and stuff like that sitting on a desk. That's my system, but it's supposed to be fast, at least I thought it was. And that's a useless slide. And so I tested these libraries using that benchmark. I'll just give away the surprise. On the Mac, you got times on the benchmark over 30 seconds, okay? Using the standard R BLAS. But when you use OpenBLAS or Accelerate, those times are significantly reduced. Like this is hard to describe without making you sit through the pain of waiting for this thing to finish running. Because when you're sitting there, and actually we all know this, when something takes a long time to run, it really takes us out of what we're trying to work on, right? You just sit there and you leave it to run, and you start getting antsy, and you go to the refrigerator, or maybe that's just me. But it's hard to stay in a flow.
What, 30 seconds or 30 minutes?
These are seconds. Sorry, I should have labeled the axis. It's a relative thing, right? So we're talking about ratio, and these are scaling. So it'd be minutes or seconds. Yeah, it is a very crazy boost, and it makes a huge difference. I actually, when I was running it on my system, I actually walked away when I was running this one, and I sat there and watched it because it was kind of cool when I was running this one. That really makes a big difference. And then, of course, if you think about long-running programs where you're doing tons and tons of these calculations, it'll add up. And here's on my system. So the reason I thought that I was so upset because I posted that benchmark thing onto the Slack channel and asked people to participate. And Jew participated, Michael participated, some other people elected not to. They were a little embarrassed. But the idea was just like, let's see what's out there. Let's see what all our systems are. And a lot of us were in the 25 to 40 second range. Almost all of us, except Amanda. Amanda came back with her MacBook Air. Now, Michael, I don't know if you have your laptop here with you, but Michael's laptop is like a massive gaming laptop. And I described my workstation to you already. Amanda came back with like 6 seconds. And we were like, no. She must have like run the test wrong or like deleted some lines or broke it. And so we went back and forth trying to test this and we were like, what the heck happened? And we were all just like, oh my God. Our computers that we thought were so cool are slower than a MacBook Air, and it was really deflating. And it turns out that Amanda had installed R using Brew. How many of you guys are Mac users that use Brew? Please go and reinstall R with Brew if you didn't install it that way. Because Brew, in its formula to install R, automatically compiles against Accelerate for you. It does it for you. It's as easy as clicking install, and it does that against Accelerate for you. So out of the box, without her even knowing it, She had optimized her system and was kicking our butts until I compiled against OpenBLAS and MKL, and then my system's still faster. So I felt better. I was redeemed. Also, I'm so glad that I came across this because, you know, I would much rather be writing my programs than running them faster. And that's kind of the message is these things are worth it. Okay? Yeah.
So does Intel have a R library?
That's a good question. I wasn't going to get to that, but that's actually a really good question. So Microsoft has R Open, which is it's free, but it's got its own it's its own license, its own separate thing. But it's got its own flavor of R, which compiles against MKL, but not by default. You still have to. I mean, you still have to tell it to do that. But the R Open will compile against MKL. It's well documented on there, but you don't have to. All of these were from just regular R from that page I showed you, just compiling it different ways. And I'm going to tell you just really briefly before I stop what that means. For those of you who are Mac users, the message is clear. Just use brew, and it will take care of it for you. It'll go really fast. And as you can see, accelerate versus OpenBLAS accelerates a little faster. MKL is slightly faster than accelerate, but it's not significant. For Linux users and Windows users, things are a little more interesting. It's a little bit of a pain. I was trying to install all these things side by side, so that maybe that added to my pain a little bit. But if you guys want, take a look at these links. I found these very helpful. Or if you want, just send me a message and we'll maybe work on it over a beer or coffee or something. We can get it figured out. It is tractable. I said there was a caveat. This isn't going to help you with everything. This isn't going to make everything you do in R faster. There's some things where you're increasingly in R, you're just using R for taking data in and maybe writing it out, or you're basically, let me show you an example. So Jeff had, for his data jam, I'm kind of picking on him, he's not here. He basically, he was grabbing a bunch of data. He then wanted to maybe clean up the names or clean up some of the terms, clean up some of the data, and then he wanted to map the data, okay? And so there's a lot of stuff with him subsetting and then mapping the data. This isn't going to make any of this faster. You maybe could try to write your data cleaning stuff in a way that would take advantage of this, but really when you're just scripting this way in a very kind of imperative manner, it's not going to make that much faster. Similarly, this pipe fitter package, which of course, I linked to the wrong thing, which of course I wanted to highlight, which is our very own, our user group package that we made that basically just takes code that's with nested functions and then rewrites it as pipes using dplyr. That's also not going to take advantage of this. It's certainly not going to hurt you when you're doing this type of program, but it's not going to help you. There's one place where it could hurt you, and I'll just let you know. So if you are doing parallel threads of R, where you actually have separate R processes running, and then you have, within those R processes, you have linear algebra routines that are trying to grab multiple threads, it can get a little bit weird. Your performance can actually go down. Reading. I didn't try it. And actually, this is probably most important for you for your programs. But it's something that I think it's documented, and I'm pretty sure people have figured out a safe way to do that.
I have a question related to that. When we're measuring performance for the parallelization, we're using it on a relatively small data set size or a large data set? Was it just that sometimes it can take longer because it's having to distribute that data to every core visually, and that may be why it's slowing it down. But if you have very, very large data set, one of them an algebra on, then it may work all this in each core, and then you expose data. I wasn't sure if that's maybe why it was slowing it down.
I think that's a good point. So the tests, and you should definitely take a look at that benchmark 25 script. The tests are designed to be CPU bound and not memory bound. So memory shouldn't be a problem with these tests on any modern system. But the idea of trying to move data back and forth across the cores is also minimized in that script. And really, I guess actually, now that you mention it, one of the reasons why this was taking so long is because this only runs on one core on your Mac. Your R is only going to take advantage of one by default. And when you use these other libraries, that's one of the things it does. It takes these matrix operations and then uses multiple cores as efficiently as possible. And it addresses that problem of like, how do you move the data onto and off of the cores? That's what's optimized by the different libraries. And same story here. I have 6 cores on the Xeon processor, and it was only using 1. So really, you know, if you have a good system, like, you want to be using it to its fullest.
So if you compile R, the way that you showed earlier,
Mm-hmm.
you optimize it on install
Yes,
for the setting that your machine has. So however many cores you have, it'll say.
exactly. And actually, that would be when you install the BLAS library, when it does that, yeah. And then you just point R during the compile step to that BLAS library that's been compiled.
Usually specify how many cores you have lost or registered, and you can change that after.
Yeah, and that's actually where where what we were talking about comes in. Yeah, you would actually like restrict the number of cores that are being used.
Amanda, quick question. Are there any caveats to using brew? Using R in brew, like
I haven't found it yet.
RStudio works fine and everything else works.
Yeah, it works. Yeah. Well, it did have so for the purposes of this, I used brew to reinstall R, trying to really get system loss. That was a little bit more annoying, but the default was it works so nicely. I don't even remember installing R.
Yeah, we were trying to figure out why it was so fast. So I guess if that's any indication.
There's a way to run a command on Mac and Linux to figure out what loss your R is put in. So you can check the for you go through.
Even the single core performance would be improved. I'm not showing that. I'm not showing that data here, but it depends on the operation. And the links, the references I pointed to do show that data. Yeah.
You mentioned earlier that if you are trying to do parallelization, it may be more harmful to use one of these alternative libraries. By default, they use more. Are they parallelized by default?
Yeah, it is. So does anybody else have any questions? What's that? Yeah, it was a Xeon. Mhm. Yes, actually Melvin mentioned that, but yes, that's true. An interesting history about this is a lot of these routines, like the best way to solve some of these problems, was figured out decades and decades ago. Like, these guys are so smart. They were too smart, but we have still code that was written like several decades ago that we still use, and it's still the fastest, and we're throwing it onto our, modern machines because it's just that good. Okay, I'm gonna let Elizabeth step up to the plate. We'll just take a second.